Medhavika, you have got a paper? I think I have sent you paper, right?
Yes.
On the Telegram group, I have shared your paper. I have checked it and shared it. Okay. So, Medhavika, last time we had not started any chapter, not exactly anything. But today I'm going to start with the topic of electrochemistry. Electrochemistry. In this chapter, we will study those reactions in which chemical energy is converted into electrical energy. This chemical reaction will take place, but that energy produced in that process will be converted into electrical energy. Or if you pass some electricity in some chemical and we can produce some other chemical, reverse also. It means electrical energy into some chemical energy. Both are process in which we pass the electricity and we can get the some product, or it may be chemical energy converting into the electrical energy. Both two processes are there. So we'll be discussing those that concept where electrical energy is converted into chemical energy or chemical energy converted into electrical energy. Right? Got it? So practically in our daily life we are using some batteries. It may be your mobile phone battery, it may be your car battery, right? It may be some batteries that you're using in your watches. Small cells are there, right? Those are the application of this chapter. We call it electrochemistry. Now, the first topic that we are going to discuss in this chapter is conduction. Conduction. Basically, I'm talking about the electrical conduction, because when you talk about the conduction, that may be thermal conduction also. So we're talking about the electric conduction. Palkin, can you hear me?
Yes.
Okay, I can't see your face. The video is off. Right. So electrical conduction. This electrical conduction we will study in two different aspects. One is called as an electronic conduction, and second is called electrolytic conduction. Two types of conductions are there. One is the electronic, other is the electrolytic. When I talk about the electronic, it means I'm talking about the conduction of electricity. Conduction of electricity to the electrons. Here I have a metallic wire and I have connected it with a battery, potential difference V. And in the chapter of solid state, we have discussed that there are free electrons in the metal. So electron drift takes place. Electron drift takes place. So the electricity flows by the drift of the electrons. By the drift of electrons, we call this is a metallic conduction. we call it is a metallic conduction. We call it a metallic conduction. Metallic conduction means conduction in the metals. In the metals, the conduction takes place through the drift of electrons. So we call this is a electronic conduction, and it is also called the metallic conduction. It is also called as a metallic conduction. Getting me? Right. This type of conduction we will study in the physics part. It's a part of the physics. In your grade 12, you have complete chapter on current and electricity. Right? So that you study in the physics part. I will be discussing about the electrolytic conduction, that is conduction of electricity through the ions. Through ions. Palkit, can you hear me?
Yes, sir.
क्या हो रहा है? You are disconnecting बार बार. क्या होगा? What happened?
सर नेटवर्क इशू बीच में ऑडिबल लाइक साउंड बंद हो जाती है.
ओके, अपने इंटरनेट को ठीक करो, नहीं तो अपना सर्विस प्रोडक्ट चेंज करो. ठीक है, एयरटेल है तो जियो पर आ जाओ, जियो है तो एयरटेल पे चले, दोनों हैं तो BSNL पे चले जाए. बट गेट योर कनेक्शन, प्रॉपर कनेक्शन. राइट, मैनी वेज आर देयर. इन कंपनी को अल्टीमेटम दे दीजिए कि ठीक करो, नहीं तो डिस्कनेक्ट हो जाओ. नया मॉडल. Okay, now we have discussed two types of conduction. One is the electronic and second is the electrolytic. Electronic we'll study in physics. In chemistry we'll discuss about the electrolytic, that is the conduction of electricity through the ions. So what are electrolytes? Anyone can give the answer? What are electrolytes?
Sir, a process in which compound dissociates into positive and negative ions.
Okay, this is a very childish answer. Sixth class student give this answer. Andre, can you tell me what do you mean by the word electrolyte? No. Okay, then right now. Electrolyte is a substance. Electrolyte is a substance that does not conduct electricity. Does not conduct electricity in solid state. But conducts in molten or aqueous state. That conducts in the molten or aqueous state. Which does not conduct electricity in the solid state, but conduct in the molten or aqueous state. That is called as electrolyte. Let us take up an example here. Suppose I say I have a sodium chloride. This is solid. Across it we connect with a wire with a potential difference. And on the track, on the wire, we put here a voltmeter or ammeter or galvanometer or any LED bulb, anything that can detect current, what do you suggest? Current will be there or not? No, yes. No. It means this solid sodium chloride acting like an insulator. Acting like insulator. It is an insulator. It does not conduct electricity. It does not conduct electricity in the solid state. But if I melt it, what do? We melt it. Upon melting, this sodium chloride gets dissociated into its ion. So here we have cation and anion. Here we have cation and anion. And now we are passing current. On the way, we put here a voltmeter or galvanometer or ammeter or any LED bulb. Anything that can detect current. What do you suggest? Current will flow or not? Will it show deflection? Yes or no?
Yes, sir.
So these ions, these are negative terminal, this is the positive terminal. So the positive terminal, positive ion move towards the negative and negative ion move towards the positive, right? Now the conduction is going on. The charge is flowing. Flow of charge is through the ions. Here we have flow of charge. Through ions. Such type of conduction is called as a electrolytic conduction. Such type of conduction is called electrolytic conduction. Understood?
Yes.
So,
Or this sodium chloride dissolved in water. Dissolved in water. When it is dissolved in water. Dissolved in water, aqua. They get again dissociated into their ions. We call them an aquasines. We call them aquasines. Again, these aquasines will move towards the oppositely charged electrons. It is called a electrolytic conduction. Understood?
yes, sir.
Right.
Yes.
Now, these electrolytes are of two types. These electrolytes are of two types. One, strong electrolyte. And second, weak electrolyte. Electrolytes are of two types. One is the strong electrolyte, other is the weak electrolyte. Strong electrolyte undergo complete dissociation into their ions. A positive, B negative. They undergo complete dissociation into their ions. It means whatever the number of particles we are adding here, A, B, they are all undergoing complete dissociation. Ashwin, what happened? You just got disconnected?
No, sir.
And weak electrolyte are those which undergo incomplete dissociation into their ions. Which undergo incomplete dissociation to their ions. Incomplete dissociation into their ions. Right? To explain the complete or weak, we have a term known as a degree of dissociation, denoted by symbol alpha. That stands for out of total number of molecules, number of molecules getting dissociated means how many particles got dissociated out of number of particles is called as a degree of dissociation. Out of total number of particles, how many particles got dissociated, that is called as a degree of dissociation. In case of a strong electrolyte, जितने पार्टिकल आपने ऐड किए, total number of particles and number of particles getting dissociated, they both are equal. All the particles getting dissociated. So I can say alpha for the strong electrolyte is equal to 1. Alpha for strong electrolyte is equal to 1. All the particles are getting dissociated. All the particles getting dissociated. It means out of total number of particles we have added, and the dissociated particles are equal. All the particles getting dissociated. So we say alpha is equal to 1. Degree of dissociation is equal to 1. Understood? See, if I multiply this alpha with 100, I will get a percentage of dissociation. So write down a percentage of dissociation is 100% in case of strong electrolyte. Percentage of dissociation is equal to 100%. Understood? Anyone?
Yes, sir.
Yes,
Okay. Now, in case of the weak electrolyte, all the particles are not getting dissociated into their ions. So here alpha is less than 1. Here alpha is less than 1. Understood?
Yes,
yes,
sir.
Okay. Now, next write down factors affecting electrolytic conduction. Factors affecting electrolytic conduction. Number one, it depends upon nature of electrolyte. When you talk about the nature, it means that depends upon the size of the ion, and number two, it depends upon the charge of ion. Number one, it depends upon the size of the ion. Number two, depend upon the charge of the ion. Now, I'm saying I have molten lithium chloride, sodium chloride, potassium chloride, rubidium chloride, cesium chloride. Right? These are there. They are getting dissociated into their ions. They are getting dissociated into their ions. When they get dissociated into their ions, what happens? As you go down the group, the ionic size of the cation goes on increasing. Can you see that? As you go down, the size increases. So as the size increases, the bulkiness increases. You can say as we go down the group, ionic size increases. I can say the bulkiness increases. If the bulkiness increases, the mobility means movement. What will happen to the movement? Mobility. Increase or decrease?
Decrease.
Decrease. So the mobility will decrease and hence the conduction will decrease. Electrolytic conduction will decrease. It means I can say lithium ion, lithium chloride will be moving very fast, and the conductivity due to the lithium chloride will have maximum conductivity. As you go down the group, the conductivity goes on decreasing because of the bigger size of the cation. Understood?
yes,
Yes, sir.
And now, it means one is the size factor, and number two is the charge factor. Suppose I have a sodium chloride, and second compound is a magnesium chloride, MgCl2. Both are in the molten phase, right? In the molten phase, here I have a sodium ion, chloride ion, and here we have a magnesium ion and a chloride ion. And now we are passing the current, negative terminal, positive terminal. Now, can you tell me in which case we'll have more conductance?
Magnesium chloride.
Reason? मेधावी,
Because as you
हाँ,
Because of the charge.
अगर चार्ज ज्यादा होगा तो बच्चे समझिए, चार्ज ज्यादा होगा तो इन आयंस के बीच में अट्रैक्शन ज्यादा हो जाएगा, इसके बीच में इंटर आयनिक अट्रैक्शन बढ़ जाएगा। अभी रिसेंटली आप फिजिक्स में पढ़ रहे हो ना ये वाला फॉर्मूला, कूलम लॉ, F is directly proportional to Q1 Q2 upon R square। ये सुनो, इलेक्ट्रोस्टैटिक्स पढ़ रहे हो नहीं पढ़ रहे हो?
Yes.
हाँ, तो उसमें पढ़ा है ना
Yes,
आपने।
sir.
तो अगर चार्ज का वैल्यू बढ़ गया है तो अट्रैक्शन विद द आयन विल इंक्रीज। If the inter-ionic attraction increases, their mobility towards the electrode will decrease, and that is why sodium chloride will conduct better as compared to the magnesium chloride. Greater the charge, more the inter-ionic force of attraction. More is the inter-ionic force of attraction, and that is why they will have more less conduction. Sodium chloride has a more conduction as compared to magnesium chloride. The sodium chloride has more conduction as compared to the magnesium chloride, and aluminum chloride will have even less because यहाँ पर charge +3 होगा. Greater the charge, more the interionic attraction, lesser the conductivity. Write it down. More the charge, more the interionic force of attraction, and lesser is the conductivity. And lesser is the conductivity. Am I clear?
Yes.
yes, sir.
Next is the nature of solvent. Nature of solvent. Sodium chloride dissolved in water or sodium chloride dissolved in alcohol. Can you tell me in which case we have more conductivity? सोडियम क्लोराइड किस सॉल्वेंट में ज्यादा डिसोसिएट करेगा? सोडियम क्लोराइड किस सॉल्वेंट में ज्यादा डिसोसिएट करेगा? वाटर में या अल्कोहल में? किसमें ज्यादा डिसॉल्व हो जाएगा? आपने सॉल्यूशन चैप्टर पढ़ा है ना अभी आपने? यस में दावेगा Ashwin? No idea. Akshat?
Sir, water.
Water. क्यों water क्यों? Why not alcohol? Yes. Why not water? Why not alcohol? Water has a dielectric constant how much? 80. And ethyl alcohol has dielectric constant only 33. More the dielectric constant, more the polarity, and more the dissociation will take place. Right? बताया था मैंने solubility के केस में. It depends upon the nature of the solvent. The compound that is more polar will make the ions easily. More ions are formed in case of NaCl. More sodium chloride will be dissolved. And that is why conduction in water will be more as compared to that in the alcohol. Getting me, everyone? Vedavika?
Yes.
Yes, sir.
Okay. Palkin?
Yes, sir.
Okay. Next, it depends upon the solvation or hydration of ions. Solvation or hydration of ions. Solvation or hydration of ions. Now, suppose we have lithium chloride dissolved in water. Then lithium ion and chloride ion, they are found to be hydrated ions. Can you tell me the meaning of the word hydrated ions?
So when it is dissolved in water and the energy is produced.
This lithium ion is surrounded by water molecules. Oxygen, partial negative, partial positive. So this is interacting with the water molecule. The ion, lithium ion is attracted by the water molecules. A large number of water molecules surround the lithium ion. Now my question is, if I talk about a sodium ion, that is also surrounded by the water molecule. My question is, out of sodium ion and a magnesium, sodium, lithium ion, which is more hydrated or more number of water molecule will be surrounding the ion, lithium ion or the sodium ion? Akshat, I'm not getting you. Could you please speak louder?
The lithium ion.
Lithium ion. Why?
So because it has the smaller ionic size.
Yeah, it has smaller size, right? So it has a high charge density. High charge density. More the charge density, more the attraction for the water. So let it be lithium is surrounded by the 6 water molecules. Sodium is surrounded by the 5 water molecules. As the size will increase down the group, the hydrated ion will decrease. Right? Radius of the lithium ion will be bigger as compared to sodium ion. Is that clear? I'm not talking about the ionic radii. I'm talking about the hydrated ionic radii. Palkin, getting me in the meaning of the two? If I talk
Yes,
about
sir.
if I talk about the lithium ion and sodium ion, which is having bigger size, can you tell me?
So the lithium.
अरे,
No, he said sodium because lithium is smaller in size
हाँ,
compared.
पलकिन थोड़ा फोकस होके बैठो. Focus, alert. Okay, now if I talk about the hydrated radii, hydrated sodium ion hydrated. Out of these two, which will be more hydrated, which has a bigger size now?
Lithium.
Lithium ion. I'm talking about the radius. If the radius is more, the bulkiness will be more. If the bulkiness is more, the mobility will be less. Mobility will be more for the sodium ion. Am I clear?
Yes.
And more conduction will be there.
Yes, sir.
It means sodium chloride will conduct better as compared to the lithium ion. Is it clear?
Yes, sir.
Yes, sir.
Now, next I'm talking about the word dilution. Medhavika will tell me what do you mean by the word dilution. Medhavika, what is dilution?
When we add water.
Yeah, when we add water. Okay. It means addition of the solvent to the solution is called a dilution. Dilution means what? Addition of solvent to solution. When we add solvent to the solution, what happened to the volume of solution? Vulcan.
The dilution will increase.
Increase the volume. Dilution will increase the volume. If the volume increases, the interionic distance. What will happen to the interionic distance? What will happen to the interionic distance? The ions will be what? What will happen to ions? Suppose here we have, in this volume, we have 100 ions. And now we have diluted it and we have made the volume bigger. The same number of ions will be now scattered, yes or no?
Yes, sir.
So what will happen to the interionic distance? What will happen to the interionic distance? Please speak fast.
Increase.
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 Increase. If the interionic distance लास्ट मीटिंग में थे आप कि चले गए थे
थी
हम्म
सर थी
okay so if the interionic distance increases here we know that q1 q2 upon r square the r will increase the attraction will decrease yes or no
Yes.
if the attraction means interionic attraction decreases what will happen to the mobility if the ions are now less attracted with each other mobility will
Please.
increase, and thus the conductance will increase. And thus the conductance will increase. Everyone got it?
Yes, sir.
Yes, sir.
Right. Now, this is what I have explained in the dilution. Dilution means addition of water. In case of a strong electrolyte, right, they are completely dissociated. The ions will move away from each other. If they move away from each other, the mobility will increase. Right. But in case of weak electrolyte, I'm talking about the weak electrolyte. For example, we have an acetic acid. It undergoes incomplete dissociation. It undergoes incomplete dissociation. With dilution, when we add here water, water provides some energy, we call it as a hydration energy. We call that is hydration energy. This hydration energy will break the ions more ionization will take place. More ionization will take place. More ions are formed. I can say number of charge carriers will increase. If the number of charge carriers increases, conduction will increase. Understood?
Yes.
Yes, sir.
So in both the cases, whether it is a weak electrolyte or it is a strong electrolyte, the conduction increases with the increase in dilution. Am I clear?
Yes, sir.
Right. Now we talk about the temperature. What is the effect of temperature? What is the effect of temperature? What do you think? What should be the effect of temperature?
The conduction will increase.
In case of a strong electrolyte, you tell me in case of strong electrolyte. This AB salt is there. It is dissociated into the ions already. Whether temperature low or high, doesn't matter. Right. But with rising temperature, what will happen? The kinetic energy increases. Because we know that kinetic energy is equal to 3 by 2 kT. When temperature increases, the kinetic energy will increase. If the kinetic energy increases, the mobility of the ions will increase. If the mobility increases, conductance increases. If the mobility increases, the conductance will increase. Am I clear? Mobility
Yes.
means movement. If the mobility increases here, the conductance will increase. This is in case of a strong electrolyte. Note it down. Understood? Note it down.
Yes.
Now,
Yes, sir.
in case of a weak electrolyte, for example, we have this acetic acid. It's a weak electrolyte. It undergoes incomplete dissociation into its ions. Okay, tell me, thermodynamically, this ionization is weak or strong? What is suggest?
Sir, please repeat the question.
This dissociation process is endothermic or exothermic?
Sir, X.
If you have to break the bond, energy has to be given or energy will be released. Basically, we are breaking the bond, right? बॉन्ड तोड़ रहे हैं, तो बॉन्ड तोड़ने के लिए आपको एनर्जी चाहिए या एनर्जी रिलीज होगी?
Energy will be,
Release.
I'm not getting you. Repeat, please.
sir, it will release.
Okay.
Yes, sir.
Okay. एनर्जी रिलीज होगी. Okay. एक काम करते हैं. I have something here, right? कुछ पेपर है मेरे पास में. Just a second, please. Okay, देखिए. Can you see my screen? Can you picture? Can you see me?
Yes, sir.
Yes,
अगर
sir.
अगर मुझे ये बॉन्ड तोड़ना हो तो मुझे एनर्जी लगानी पड़ रही है या एनर्जी रिलीज हो रही है?
लगानी पड़ रही है.
तो आपने ऑक्सीजन और हाइड्रोजन के बॉन्ड को ब्रेक करना है तो एनर्जी लगानी पड़ेगी या फिर एनर्जी रिलीज होगी?
लगानी पड़ेगी.
लगानी पड़ेगी.
लगानी पड़ेगी.
तो ये एंडोथर्मिक होगा एक्सोथर्मिक होगा?
Endo-
Endo.
एंडो.
एंडोथर्मिक. backward will be exothermic, right? Getting me? To break the bond, we require energy. And we know, according to the Lee-Chatelier principle, endothermic reactions are favored by high temperature. Yes or no?
Yes.
It
Yes,
means when
sir.
we raise the temperature, the endothermic will be favored. It will go in the more the forward direction. If it goes in the forward direction, number of ions will. What will happen? Number of ions
Increase.
increase.
It
Number
will
of
increase.
so the number of charge carriers will
Increase.
increase. If the number of charge carrier increases, the conductance will
Increase.
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 So write it down step by step. With rise in temperature, this degree of dissociation increases. This will be increase in number of ions. This will increase the number of ions. As the number of ions increases, number of charge carriers will increase. As the number of charge carrier increases, the conductance will increase. Understood? Yes or no?
Yes.
Yes, sir.
So these are the factors on which the rate of reaction, which influence the conductance. We call electrolytic conductance. Till now, any doubt? No doubt?
No, sir.
Right. So prepare well the whole topic. Right. Okay then. See you tomorrow now at the same time, sharp at 9 o'clock. Right. And Palkin, take care of your Wi-Fi or connection. रुकना नहीं चाहिए क्लास में. Okay then.
Yes, sir.
Okay then. Goodbye. See you tomorrow.
Thank
Thank
you,
you,
sir.
sir.